Good morning, everybody. Good morning. Let's start. So this chapter is about analog transmission. Okay. So can you close the door, please? Can you close the door? Can you close the door? Okay, so this chapter is about analog transmission, which means if you have binary data ones or zeros, so we are gonna convert. We're not gonna unlike the previous chapter. In the previous chapter, we transmitted digital signal, but this chapter we convert or we transmit analog signal. Okay, so for example, you have 0 and 1. For 0, there is an analog signal. For 1, there is a different analog signal. So if you want to transmit 0, you have to transmit this one. If you transmit 1, transmit the other one. Okay. And I told you the way you are going to do it, we are going to do it. Can we listen to me? So as I told you, the way you are going to do it is we are going to have different techniques. So the first technique I explained last time, we call amplitude shift keying. So very simple. In amplitude shift keying is I'm going to change, as I said before, any signal has 3 main parameters. It has amplitude, it has frequency, it has phase. So in this one, I'm going to change the amplitude, but I'm not going to change the frequency. I'm not going to change the phase. You get what I'm saying? So here, we're going to use 2 different amplitudes. One amplitude for 0 and one amplitude for 1. Okay? At the receiver side, I'm gonna measure the amplitude. If the amplitude is for 0, that means you transmitted 0. If the amplitude is for 1, that means you transmitted 1. Here, I'm gonna use 2 different frequencies. One frequency for 0, one frequency for 1. I'm not gonna change the amplitude. I'm not gonna change the phase. Only change the frequency. At the receiver side, when I receive a certain frequency, I can know if you transmitted 0 or 1 from the frequency. Same thing here. Here, I'm gonna transmit 2 different phases. Okay, phases. One phase for 0, one phase for 1. At the receiver side, it has to see which phase you have transmitted. Okay, this one, as I'm going to explain today, this one actually is going to combine these 2 together. But let's. So last time I explained amplitude shift keying. The very simple way to do it is I'm going to have what we call carrier frequency, and then if I want to transmit 1, so I'm going to transmit the carrier frequency. Otherwise, I'm going to transmit 0. So 0 is actually like a sine wave with amplitude 0. So here, one of them is amplitude 0. The other one is at a certain amplitude. As a receiver side, it has to check if the amplitude is 0 or not. Okay, and I told you last time, if this is this signal, in order to transmit this signal needs this range of frequencies. To transmit the signal, I need this range of frequencies. Okay. And the frequency at the middle here, we call it carrier frequency. Also, I told you here, the bandwidth is actually 1 plus d times n. And the n here is actually n. And d is a constant value that can take a value from 0 to 1. Is that okay? I told you last time also this is good. The bandwidth is very good. It's very good bandwidth. Okay. It's very simple to do it. You just use a simple multiplier. So it's very simple to do it. Very good. The only problem we have here is, do you remember from last time what was the main problem here? Noise. Because noise has big impact on amplitude. Because here I depend on the amplitude, right? In order to differentiate between 0 and 1, I need to measure the amplitude. The noise is going to change the amplitude much easier than it changes the frequency here or it changes the phase here. Again, I'm going to say it again because it's very important. Noise can change the amplitude of the signal much easier than it changing the amplitude or the frequency. That means this technique is vulnerable to noise more than these 2 techniques. That means FSK and BSK are more resistant to noise because the noise, it's not easy for noise to change the frequency or the phase. It's easy to change the amplitude. Is that okay? So this was the problem. And now we're going to move to the next one. In the next one here, we put frequency shift keying in the next one here. And the idea, similar to what I explained, I'm going to use two different frequencies. One frequency for 0, one frequency for 1, as you see here. So every time I want to transmit 1, I'm going to transmit this frequency. Every time you transmit 0, I'm going to transmit this frequency. At the receiver side, it has to see what is the frequency. If the frequency is this one, so that means you transmitted 0. If the frequency is this one, so that means you transmitted 1. Is that okay? Any questions? Okay. So now, if you look at the bandwidth, what is the frequency domain of this one? Oh, sorry, the frequency component of this one. So if you see the frequency component of this one, it's going to look like something like this. It's going to look like this one. Okay, what is this? Okay, I'm going to tell you what is this. So actually, this is the bandwidth from here to here. This is the bandwidth. This is the bandwidth from here to here. But actually, if you are, for example, assume F1 is here for 0. Assume we're going to use F2 for 1. As that. Okay. That means at the receiver side, if I receive a signal in this range, that means it is 0. If I receive signal in this range, that means it is 1. Okay. At the receiver side, I can use two filters. I can put one filter here and I put another filter here. Band pass filter. Okay. If this band pass filter give me 0, okay, that means the signal, and this give me a voltage, that means the signal is here. Okay, or my signal is here. And because the signal is here, you're transmitting 0. If the signal is 0, you're transmitting 1. You understand what I'm saying? Any questions? So again, this is just one band, but this band, because we are using two different frequencies, is gonna be divided into two parts. One part for 0, so only one of them should be active at a time, right? Either you transmit this one or this one. Any questions? I'm quite sure what I'm gonna explain right now is it will confuse you, but there is a big. They look the same, but they are not the same. There is a big difference. Last time I explained something like that for amplitude shift K. I told you here, what if you want to do bidirectional transmission? I told you before, what happens in reality, we have bands here, one band, certain range of frequencies, okay? So you can have here one transmission here, one transmission here, one transmission here, and so on. I told you last time, if you want to do full duplex, so I can have two bands, as you see here. I can use this band, and you can use this band, okay, for bidirectional, okay? Again, what is the confusing part? The confusing part is, look here. Here in this band, you actually here is going to be 0 or 1. So either you transmit 0 or 1 is going to be here, right? Because this is a complete band. But what happens here, and this may be confusing to you, these are not two bands. These are not two transmission. It's only one band. This is not two bands. It's only one band, one transmission. You understand what I'm saying? It's not two. They look like two, but they are not. Okay. So actually, this is only one band. So if I give you this band, it's not enough for transmission. You have to give me two. You have to give me this part here. And then I'm going to divide it into two parts. One part for 1, one part for 0. You understand what I'm saying? So although this figure is very close to this figure, but big difference. These are two different transmission. In this part I can transmit 0 or 1. In this part I can transmit 0 or 1. But here it's a completely different. It's one band. So I can here I'm going to use this one for 0 or 1. The other one is going to be for another bit. Any questions? I'm going to give you, sorry. No, either I transmit either 1 or 0, right? In a certain time. So this is the whole bandwidth given to you from the network. This is the whole bandwidth. You are going to cut it almost into half. Is that okay? And at a certain time, either I'm going to receive a signal in this range or a signal in this range. Because at a certain time you are transmitting either 0 or 1. Okay, so now I want to calculate the bandwidth. Okay, so the bandwidth here, as we see, is actually the bandwidth is from here to here. This is the bandwidth. Okay, if you see here, from here to here, this part here is actually S times 1 plus D. This part, okay? Same thing for this part, S times 1 plus D, okay? Sometimes we have like here in the middle, we put what we call a guard band in the middle here. A guard band. Separation. I want to separate between them. Why? Because at the, I actually, I'm going to use a filter here. I'm going to use a filter here. If there is no separation, if there are something like that, no separation this way, that means I need a very accurate filter that can differentiate between them very well. You know what I'm saying? So usually we see a space, right? In order to separation, in order to make it easy for the filter to be able to differentiate between them. You understand what I'm saying? So here, so again, bandwidth, that means from here to here is the bandwidth, from here to here, all of that. That's okay. Now I'm gonna define a new parameter, which is from F1 to F2. So from here to here, this one, I'm gonna call it 2 delta F. So D here means delta. So 2 delta F. So from F1 to F2 is actually 2 delta F. Is that okay? Okay. And what about this part? It's called 2 delta F. Delta means the difference between F1 and F2. So delta F means it's just one term. Okay. So just one term, 2 delta F. So here, actually, this part here is going to be half S 1 plus D. Because as you see here, from here to here, it is S times 1 plus D, half and half, because F1 is in the middle. F1 in the middle, F2 in the middle. You got what I'm saying? So this part here, half is the same thing here. Another part here, half S 1 plus D. Makes sense? Because this is half and another half here. Because F1 is in the middle, half and half. Okay. So now I want to calculate the distance from here to here, or I want to calculate the bandwidth from here to here. Okay. So I have half. I have half here, another half here, plus 2 delta F. That's why the bandwidth is half and half. It should be 1 plus ds plus delta plus 2 delta F, which is from here to here. Any questions? Okay, so I want to measure from here to here. So I have to get this one, 2 delta F. That's easy. Half S 1 plus D. Why? Because this one is exactly in the center. So this one half and this one is half. Add them together, we are getting the formula right there for bandwidth. Is that okay? Yeah, this formula here for the bandwidth. Any questions? Okay. Let's now calculate the minimum bandwidth you need. Minimum. The minimum is, assume you have a sober filter and you don't need a guard. So this will give you the minimum. So here, I'm going to cancel this part. This is the minimum frequency you need. For sure, you need something greater than that to add the separation. But assume I'm not going to add separation. Is that okay? So the minimum frequency, B minimum, as you see here, minimum frequency should equal this part plus this part. Is that okay? Which is 2 S 1 plus D. Makes sense? Because this one from here to here is S times 1 plus D. I'm going to cancel the separation. This one also S 1 plus D. So the minimum frequency I need actually 2 times S 1 plus D. Any questions? Okay. And now, as I told you before, D is constant. D is constant. It's going to be given to you. It's going to have a value between 0 and 1. What is S? I told you also before, S should equal N, the bit rate, times 1 over R. And in this case, R here, in this case, R is 1. What is R? R, I'm going to transmit one bit in one signal element. So 1 divided by 1. 1 bit divided by 1 by 1. So R is 1. Okay. So anyway, in conclusion now, the minimum bandwidth is actually equal, okay, to S, which is N, 1 plus D. Okay, this is a relation between bit rate and bandwidth. Okay, any questions? Any questions? Good. So now I'm going to explain how can we implement this idea in reality. So in reality, we use something. We take a seat quickly. You make a lot of disruption. What's the time now? 14 minutes. Anyway, so here, how can we implement this idea in reality? Okay, I told you before we have something called oscillator, right? Oscillator is an electronic circuit that generates a sine wave with a certain frequency. Is that okay? Okay. We have also electronic circuit. We call it VCO, or voltage controlled oscillator, VCO. Okay. The way it works is that it's an oscillator. So VCO, it's an oscillator. This oscillator has output and it has input. Okay. The input here is a voltage. The output here is a sine wave. Okay. However, the frequency of this sine wave is proportional to the voltage. Not proportional. I can control the frequency using the voltage. Given if different voltages, you are going to generate different frequencies. You understand what I'm saying? So there is a circuit. This circuit is called VCO. In this circuit, by changing the input voltage, you are going to change the output frequency of the oscillator. Okay, and that's exactly what I need now. So if you see here, if I want to implement this idea the way I'm going to implement it, so as you see here, all what I need two frequencies. In order to get two frequencies, I need two voltages. That's it. So if I apply here two different voltages, I'm going to get two different frequencies. And that's exactly what I can do here. So this is the signal. We have 1, 0, 1, 0. So I have a voltage for 1. I have another voltage for 0. Is that okay? Two different voltages. 1 voltage for 1, 1 voltage for 0. And then I'm going to input it here. That's it. By changing the voltage, you are going to change the frequency of the output signal. That's it. So as you see here, when it is positive or in this voltage, I'm going to get this signal. When at this here in this one, I'm going to get this one. Okay. Any questions? No, this is electronic circuit. This circuit, by changing for every voltage, is going to generate different frequency. So in this case, all what I only need two voltages, two different voltages, right? So that for every voltage, it's going to generate different frequency. Okay. I want to tell you something here, maybe a little bit confusing, but usually, as you will see right now in the following example, I'm going to give you an example now, but in this example, again, this is one band. As I told you, this is just one band, okay? Here, if I ask you, and here, I'm going to use F1 and F2. This is the two frequencies I'm going to use, F1 and F2, okay? If I ask you, what is the carrier frequency, okay? Carrier frequency actually is the frequency at the middle here. So always the frequency at the middle, we call it carrier frequency. The middle of your band. Do we use it? No, we don't use it here. Because here we use F1 or F2. We don't use the carrier frequency. But always, when I tell you what is the carrier frequency, for example, if I come here, this is for the amplitude shift. The carrier frequency is the frequency it's at the middle. Do I use it? The answer is yes, I use it because this is carrier frequency. I use it here, right? But here we don't use the carrier frequency. But if I need to ask you, when I ask you to calculate the carrier frequency, you have to see what is the band you have. This is my band. So the carrier frequency has to be the one at the middle, right? So the one at the middle is the carrier frequency, and then this band, as I told you before, we're gonna use it, or I'm gonna leave a small space. Okay. Also here I'm gonna leave a space here, and then I'm gonna use one band for 0, one band for 1. This part or this part for 0, one part for 1. Okay. But just to make it simple, we may ignore the separation, but in reality, you have to leave a separation. Okay. So let's see an example here. So here in this example, I'm telling you we have a bandwidth of 100 kilohertz, okay, and this one spans from 200 to 300 kilohertz. Is that okay? So let me draw it here. So here I'm telling you, starting from 200 to 300 K. Okay, and then yeah, from here to here is 100 K. This is the okay. This is the band, the whole band. Okay. If I ask you what is the carrier frequency, so the carrier frequency has to be at the middle here. This is the carrier frequency. So as you see, this part here is 50, and this part actually is 50, 50 and 50. So this one should be 250 hertz. 250 hertz. Is that okay? Okay, great. And now, just to make it simple, assume there is no guard, no guard. So I'm gonna use this part here. I'm gonna also use this part. There is no guard to make it simple. Assume there is no guard. Okay, there is no guard frequency here. If I ask you what is F1 and F2, how can you get F1 and F2? F1 is actually in the middle here, right? And F2 is the middle here. So if you want to get F1, so here it has to be. This is 50, so that means 25 and the 25. So it should be 175K. 175. I'm right? I think it's I think it's wrong, right? So it has to be, yeah, you are right. So here 225, yes. 225, that's true. Okay. So what about this one here? Should be from here to here, I have to add 25. 275K. Yes. So this is F1 and F2. Okay. Now I can ask you to calculate the bit rate. What is the bit rate? As I told you, we have B minimum. B minimum should equal 2 times 1 plus D times N. Times N. Okay. So in this question, I give you the bandwidth, which is from here to here. So the bandwidth is actually 100 kilohertz. This is the bandwidth. D given to you by 1, and now you can get N. You got what I'm saying? Assuming there is no guard, you can get N. And that's exactly what I did here. So what I did here, you calculated it, I found it's 25 kilobit per second. Any questions? Okay. So now I told you, now here in this example, we have 2 levels. That's why we need 2 different frequencies. Is that okay? What if I have 4 levels? What if I have, 4 or 8 more levels? Okay. What if I have 4 levels? How many frequencies I need? I need 4 frequencies. Is that okay? For example, here, I have here 0, 0, I have 0, 1, I have 1, 0, I have 1, 1. So for example, here, I'm going to use F1 here, F2 here, F3 here, and F4 here. Make sense? 4 frequencies. As a receiver side, when I receive F1, I understand you are sending 0, 0. When I receive F2, so I'm going to understand you are sending 0, 1, and so on. Is that okay? What if I have 8 levels? 8 levels, so I need 8 frequencies. Make sense? Okay. And this is, but now I want to tell you something here. This formula is going to change. This formula is used if you have 2 levels. If you have more than 2 levels, so I'm going to give you now a general formula. Okay? So the general formula is this one here. So here, bandwidth is 1 plus S. So this part is similar to the previous one. It's similar, right? The only difference is here. This was 2 details. Okay, but now if you have, I'm gonna tell you how I come up with this one. But anyway, so here L minus 1. L is the number of levels. You get what I'm saying? So the whole bandwidth is going to be L minus 1 times 2 delta F, and it's going to be this way. This is a general formula. So if you put here L by 2, so actually, so this part is going to be 1, and then I'm going to get this formula again. You know what I'm saying? Because this is for when we have 2 levels. Okay. So this is general for any levels. Okay. And now, assuming there is no guard, as I told you before, if I want to calculate the minimum, so there is no guard. So in this case, because there is no guard. So this actually 2 delta F here should equal to 1 plus ds. Because there is no guard. As if I go back here, if there is no guard, so this part does not exist. There is no separation here. So actually from here to here is going to be actually S times 1 plus D. Okay. So it's going to be, yes. So this part is going to be 1 plus D times S. Okay. So if you do the calculation here, this is 1 plus D delta S. And now we have negative this one. So if you do the calculation, it's going to be 1 plus D S times L 1 plus ds minus 1 plus ds. So this one is going to go with this one. So the result, and this is the minimum frequency because I cancel the guard. This is the minimum. It's going to be L 1 plus ds. That okay? If G is 0, so it's going to be actually LS if G is 0. And that's what I'm giving you. So this is just a special case when G is 0. But in general, the minimum bandwidth when I cancel the guard band, so it's going to be actually L times 1 plus ds. And what is S? S here actually N times 1 over R. Okay. And you need to know what is R. R is actually how many bits you transmit, number of bits in every one signal element. How many bits? So if I transmit 3 bits, should be 3 divided by 1. Okay. If I transmit 2 bits, it should be 2 divided by 1 in every signal element. So in this case here, we only transmitted 1. In every signal element, we transmitted only 1. That's why R was 1. But in this multi-level, R can be 2 or 3 and so on. Any questions? Okay, let's explain this example. I want you to focus because it's a little bit confusing. It's not hard, but a little bit confusing. Okay, so now here I wanna, and very important, maybe I'm gonna bring something like that, but I'm gonna change it a little bit in the maybe. Okay, so you need to pay attention to it. So here I'm telling you I'm gonna transmit 3 bits. Okay, so here I'm gonna transmit 3 bits at a time. So when you transmit 3 bits, so every time you transmit 3 bits, so how many levels you have? 2 to the power 3, which is 8. So that means we have 8 levels. Okay, why? We have 8 levels simply because you transmit 3 bits. So we have here 3 zeros, we have 3 ones, 1 0 0, 2, and so on until 1 1 1. Sorry, 3 ones. So if you see here how many different cases you have, so I should have 8 cases. 2 to the power of 3 is 8. Is that okay? So I have eight different levels. So how many frequencies I need? I need 8 frequencies. Very simple. So I need 1 frequency for this one, 1 frequency here, 1 frequency here, and so on. So I need 8 frequencies. Every pattern is gonna be sent using 1 frequency. Is that okay? Any questions? Okay. So now I'm telling you in the question, I want to transmit 3 bits. So how many levels we have? 2 to the power 3, which is 8. But anyway, let's complete the question. Also, I'm telling you here in the question, I give you the bit rate. The bit rate which is N, I give you N, which 3 megabit per second. I give you the carrier frequency, which is 10. Given this information, give me everything else. I want you to draw this one. I want you to calculate the bandwidth. Give me everything else. Okay. Let's see how we can do it. So the information we are transmitting 3 bits, and from this one I can know L is actually equal to 2 to the power 3, which is equal to 8. I think they give me the carrier frequency is 10 megahertz, right? And N is 3 megahertz, right? N is 3 megahertz. Is that okay? Okay, so now Okay, very simple. So all what I have here, I have a very big band for sure because I need to transmit several things. In the middle here, it's 10 megahertz in the middle. That's what's given to me. Is that okay? Also, because I have 8 cases, 8. So I have 4 here and 4 here. Okay, so that means here I had only 2 cases. That's why I had F1 and F2 because it was only 2 cases, F1 and F2. In this case, I'm going to have 4 here. 1, 2, 3, 4. So here I have F1 in the middle. I have F2 in the middle, F3, F4. Also here, I have F5, F6, F7, F8. So I have 8. Make sense? So if you, for example, I can use this one for 0, 0, 0. If the signal you are sending to me in this range, so you are sending me 0, 0, 0. Okay? If this one is 1, 1, 1, okay? If the signal you are sending me in this range, so you are sending to me 1, 1, 1, and so on, because I have 8 different cases. I'm going to use the other one for the other case. Any questions? Okay. I need to know, number one, what is the bandwidth? I want to give it the information where I need the bandwidth from here to here. Okay. Also, I need to know what is F1, what's F2, what's F3, what's F4. Also, I need to know what is the beginning frequency and the last frequency. I want to get everything given the information you have. Okay. So let's see what can we do. Let's see what can we do. Let's start with the bandwidth, okay? I told you the bandwidth should equal 2D plus 1, right? Times L. Times N. No, something is wrong. I told you the minimum bandwidth is L times D plus 1 times N. Is that right? Oh, sorry, I'm sorry. Okay. So here it should be no, it's L times 1 plus D times S. Okay. So L, let me increase it. So it's going to be L times 1 plus D times S. Is that okay? So let's start with S. How can you get S? S actually is N times 1 over R, right? N is given to me. What is N? 3 megahertz given to me. Okay, what is R? R is actually 3 because in every one signal element we transmit 3 bits. So R, this from the very beginning, I told you the definition of R, how many bits you transmit in every signal element, in every time slot. So R here is 3. That means S here is 1 megahertz. 1 megahertz. D is 0. So I'm going this is given to you. D is 0. Okay. L is 8. L, how many levels we have? We have 8 levels. That means the minimum bandwidth I need is actually 8 megahertz. This example is very important. I didn't put the midterm yet, but I'm thinking if I put it, I may put this one. But for sure, I'm going to do some changes. It's not going to be exactly the same thing. So now the bandwidth is going to be 8 megahertz, right? Any problem? Given to you. Okay, given, because D is constant. It depends on the filtering and modulation process. So it's given to you, D is 0. Yes. So actually now, from here to here, okay. Okay, so now from here to here, it's actually 8 megahertz. Is that okay? And also I give you the one at the center, which is 10 megahertz. Okay, so this one in the center is 10 megahertz, and then you calculate the bandwidth. Okay. Let me ask you a question. Can anybody calculate the beginning frequency here? Can anybody calculate the last frequency here? That's easy. Carrier frequency always in the middle. The carrier frequency always in the middle. And I know from here to here it is 8. That's what I calculated. From here to here it's 8 megahertz. Carrier frequency in the middle. So that means we have 4 megahertz here and 4 megahertz here. Yes, 14. This one is 14. So I'm going to draw. Okay, let me erase everything here. So what I'm saying here is, look here. This is the whole bandwidth I have. I know in the middle here, this one was 10 megahertz. I know from the calculation from here to here, it is 8 megahertz. That means we have here 4 and we have here 4. Okay, so this one should be 6 megahertz and this one should be 14 megahertz. That's true. Makes sense? Great. So now, and how many different bands you have here? I told you we have 4 here and we have 4 here, right? Okay, and we have here F1, we have F2, we have F3, we have F4, and so on. Is that okay? So now, can you calculate how big is this one? Yeah, 1, because they are equal, right? So from here to it's 4, and they are equal. They are the same. So 1, 1, 1, 1, 2, 1, 1, 1. Okay. So everyone here is actually 1 megahertz. 1 megahertz. Okay. Can anybody calculate F1? No, because F1 in the middle. So here we have half here. Yeah, 6.5 megahertz. This one is 6.5. Yes, and from here to here is 1. From here to here to is 1. So 6.5, 7.5, 8.5, and so on. Okay. So if you have the carrier frequency given to you, and then all what you have to calculate is the bandwidth. After that, you can get everything else. Any questions? Yeah, sure. Why this one is 6? Because the middle frequency here, the carrier is 10. And the bandwidth, which is from here to here, is 8. The bandwidth is 8. So from here to 8. So this one is 4, and this one is 4. 4 and 4. Okay. So this one is 10, and this one is 4. So this one has to be 6. 6 plus 4 is 10. Okay. Quickly, I'm going to explain to you. I give you a formula, and I told you later I'm going to explain why. So the formula I told you, the bandwidth is equal 1 plus ds plus L minus 1 times delta F. 2 delta F. Okay. How you came up with this formula? I'm going to tell you how. Very simple. Look here. For example, in the same example I have right now. So, okay. This is the middle. We have 1. Okay. So actually, this is from F1 to F2. So this is 2 delta F. So 2 delta F is the distance between F1 and F2. It's the same thing here. Also 2 delta F. From here to here, also 2 delta F. Same thing from here to here, 2 delta F. So so here, from here to here, actually, it's going to be L minus 1, 2 delta F. The separation between F1 and F2, this by definition, 2 delta F. 2 delta F is the distance between F1 and F2, which is the same like F2 and F3, but it's the same, right? So here, 2 delta F, 2 delta F, 2 delta F, okay? This is 2 delta F, and so on. So in general, from here to here, actually, it's going to be L minus 1 minus 1, 7. In this case, it is 7, because L here is 8. In general, it's L. But here, yes, it is 7. Okay. Okay. How you came up with this part? So this is I'm explaining how, because bandwidth, it means from here to here. This is the meaning of bandwidth, from here to here. I already calculated from here to here. which is this part, from here to here. This one, plus this one, plus this one, plus this one. So all what I need, I just want to add this part plus this part, and that's it. You know, from here to here, 1 plus ds. So this part actually half 1 plus ds. Same thing here, half 1 plus df. If you add them together, you're going to get this one. That's why I'm just explaining why you have this rule. Because this formula, actually, this part here, the first part here is actually give you this part and this part. The second part is this one here is going to give you, let me use another color. Yeah. So from here to here, actually coming from this one. Yeah. So here is just a special case when L is equal to 8, but you can apply it for any other cases, will be the same. Any questions? Again, this example is important. Again, I'm not saying it will be in the exam, but I think it's important, okay? I may put it, may not, but I think it's important. Anyway, okay? Maybe I give you some information, and then I'm going to ask you to draw this one. Any questions? And also important to understand the topic, right? So here what we have, so here I'm going to give you, this is your bandwidth given to you. This is a bandwidth given to you. And this bandwidth, you are going to split it into pieces, as you see here. Every one here is going to be used for one pattern, one pattern. That means, for example, in this scenario, if you transmit here 0, 0, 0 is going to be here. If you transmit 1, 1, 1, it's going to be the other patterns are in the middle, like 0, 0, 1, and so on. What I'm saying? This is only one transmission. It's not 8 transmissions, only one transmission. At any time, you are going to transmit only a signal in one of these bands, only one. Is that clear? Any questions? As a receiver has to decide, have you transmit a signal here or here or here, in which band you transmit the signal, right? Once I know the band, or I know the frequency or the band, it's easy to know what information you send. Any questions? Okay. Next one, phase shift keying. So again, what is the problem of the frequency shift keying? The problem of the frequency shift keying is the bandwidth is too bad. It needs double. It needs double the bandwidth of the amplitude shift keying. So yes, this one forfeits the problem of the noise, okay, but it actually has the problem of double the bandwidth. Okay, so that is why we are going to move to phase shift keying. Phase shifting keying is good for noise because it's not easy for the noise to change the phase, right? Similar to the frequency shift keying, but this one is going to have the same bandwidth like amplitude shift keying. It's the same bandwidth. Is that okay? It's not double, which is good. So as you see here, so the idea here actually, we can, very simple idea, we can use actually 2 phases. We can use, so if you want to transmit 2 bits, so you can transmit 2 different phases. The easy way to do it, if you want to transmit 2 phases, is if you have a signal like this one, so here the phase is 0. Okay, if I multiply this signal by -1, you actually are going to flip the signal, and now the phase is 180. Again, because here I'm going to transmit 2 bits. Because I'm going to transmit 2 bits, I need 2 phases. As a receiver, I need, for example, I'm going to transmit this one or this one. I'm going to use 1 for 0, 1 for 1. As a receiver, it has to know what is the phase. That's it, very simple. If I want to transmit 4 levels, I have 4 levels. So I have to look for, I have to have 4 different phases. Okay. So yeah, that's exactly what I'm saying here. So for example, if I not transmit 1, so the phase is 0. Here the phase is 180 for 0, right? For 1, phase is 0. 1, phase is 0. Phase is 180, and so on. Okay. So if you see this one, the bandwidth here is actually similar to the amplitude, which half of the frequency, which is good. So frequency is good, noise also is good. Okay. Any questions? How can we implement this idea practically? The way we can implement it is we have multiplier. Multiplier is actually an electronic signal. So here we have multiplier. Multiplier is an electronic circuit. It has two input, V1 and V2, and the output of this one is V1 times V2. Is that okay? So what I can do is, look here, very, very simple. I'm going to have this signal here. And the input here is either +1 or -1. +1, for example, for 0 volt, -1, for example, for 1 volt. Okay? So when I multiply +1 by this signal, I'm going to get the same signal to the phase is 0. But when I multiply -1, so actually the phase is going to be 1 each. You got what I'm saying? So here the input is either +1 or -1. The positive one is going to give me phase of 0. The negative one is going to give me phase of 1 each, right? Yeah. So as you see here, +1 times this one, I'm going to get this one. -1 times this one, I'm gonna flip it, or it's going to be 1 each. Any questions? Okay. Now, that's what I'm explaining now. Quadrature PSK. So here we have four levels. So I'm going to transmit four levels. So here, here, as you see here, for example, I'm going to transmit either 0 0 at once, 1 0 0 1, or 1 1 at once. Okay, so here every time I'm going to transmit 2 bits instead of 1 bit. That means I need four phases, right? So here I have 0 0, we have 1, we have 2, we have 3, right? So now I have 4 cases. So I need 4 phases. Okay, that's exactly what we're going to have right now. So, for example, I'm going to use these 4 phases. Like -135 is going to be for 0 0. -45 is going to be for 1 0 for this case. +145 here. 45 is going to be for this one. So I'm going to use 4 phases. Is that okay? But practically, how can you do something like that? That's what I'm going to explain to you right now. But you understand the concept. The concept is because you are transmitting 4 different patterns. So every pattern is going to be represented by 1 phase. So I need 4 phases. Okay. So how can you do it? I have as you see here in this circuit, we have oscillator here. Okay. So, and this oscillator actually in this oscillator, so this is the signal of the oscillator here. Okay. And here is going to be 80 degrees. So I'm going to shift it by 80 degrees. So this is the signal here, input here. Okay. So this is the signal here, and this is the signal here. Okay. And so, as I told you before, this signal either I'm going to multiply it by +1 or -1. +1, I'm going to get the same signal. -1, I'm going to flip the signal. Okay. So this is here, when you multiply by -1, I'm going to get this one. So this is when I multiply by +1, I'm going to get this one. Either, so here actually, either this one or this one is, I'm going to get them here. Okay, if you multiply by +1, I'm going to get this one. Okay, if I multiply by -1, I'm going to flip it. You see, this one just flip. Okay. Same thing here. Okay, either this one or this one, I'm going to get them here. Okay, it means you multiply by +1 or -1. Okay. So let's see what happens here. Let me give you understand it. And then I'm gonna add these two signals together. I'm gonna add these 2 signals together, and the result will be one of these 4 cases. So let's have an example better to understand it. Okay. So for example here, if you here in case of 0 0, 0 0 actually here, so it's gonna be negative. Okay. So what's gonna happen? Here, because this one is -1, and also here -1. So actually we are going to take this one, not this one, because this is, I'm going to take this one if you multiply it by 1, but this is a -1. So I'm going to take this one. Also here, I'm going to take this one. And then if you add them together, you actually are going to get -135. Let's see another case. In another case, 1 1 0. For 1, it's a positive. So I'm going to get this one. Let me use another color. Okay. So here for 1 is going to be positive. So I'm going to get this one, right? For 0, I'm going to get negative. So I'm going to get this one. This is a -1. If you add these 2 together, you are going to get -45. And so on. For example, if you have 1 1, 1 1 here, so I'm going to get this -1. You multiply by -1. Sorry, 1 is positive. I'm sorry. So this is a +1. Yeah, so I'm gonna get this one after you multiply by +1. I'm gonna get this one. Also, I'm gonna get this one. If you add them together, I'm gonna get 45. Is that okay? Any questions? Just we need 4 different phases, but here I'm explaining how we can do it. Any questions? I have here very simple example. Here I'm giving you I'm giving you the bit rate, which is n. I'm giving you n. I'm telling you D is 0, and then I'm asking you what is the bandwidth. So you already know the bandwidth is actually 1 plus D, right? Times S. It's a 2 or it's a 2, right? No, 1 plus D times S. Okay, times S. And what is S here? S here is actually N 1 over R. Is that okay? So N is given to you with 12. N is 12 given to you. Now, what is R? R here. R here is R here is actually 2, right? Because you transmit two bits in every one signal element. So actually, so this should equal 1 plus 0, D is 0, times 12 times 1 over 2, which is actually 6 megahertz. Any questions? I want to tell you something at the end, okay? A little bit confusing. Listen to me. We have here 3 things that are too close to each other. We have bit rate, megabit per second. We have here S, which is a signal rate, and this one is measured in baud. Okay, and we have the the bandwidth, which is measured in hertz. You got what I'm saying? So if you measure B, it has to be in hertz. If you measure S, so a signal rate, so it has to be in baud. If you measure N, bit per second. Any questions? That's enough for today. Let's take the attendance quickly. In the homework, I was told you have to record the video. Some in the previous section, some student didn't like that. Again, this is not my idea. I was told to do that, but I'm okay. If you don't want to record the video, I'm totally fine. Okay. 2097. 2097.